Hey everybody. Okay, for those that may not know, one of the employees over at MathWorks has once again set the standards of how to author a complete high-frequency trading system. Now, I've been talking about this for numerous years. In this video, I'm going to just go over the various demos of the files, where to grab the example files, this video is over an hour and 10 minutes long. Please watch it if you want to really learn how to properly develop a trading system, not just automation, but high-frequency trading as well. So I've put together 4 lessons learned from the video. I'm going to show you some demos, and just everybody knows is that there's 2 other segments after this. And there's one on the different 2 examples of a lead lag model, also another one for strategy on the Bayesian. But the very last one's the one you want to specifically pay attention to for the high-frequency trading component, because that's using Simulink state flow. I also take it one step farther to generate code from that. I'm generating in this example C++, but you can easily do it with C. And most likely, but by no means, I'm no expert at it, but for sure, you can develop or co-generate for HDL for FPGA deployment, regardless if you have a Xilinx or an Altera board. Okay, so let's start showing some stuff. Now, again, this is the video that I mentioned for an hour and 10 minutes. There's various 2 other videos that are pretty mind-blowing on how to build out trading systems, from the computational finance head, Stuart Kozzola, over at MathWorks. He's really set the standards on how to really develop this type of system, and why you should only use Matlab or Python. Fine, I've talked about it numerous times. But with Matlab, it sets the standards on how to do it. Okay, so let's talk about what lessons should be learned from this. Number 1 is this exact same design patterns that you see in this video are pretty well used in various specific 1 or 2 multi-million-dollar systems that I've seen and viewed source code for. Okay, these design patterns that are introduced are very intelligent, and this video walks you through the entire process. You can download the source code. You can get the source code here for everything. MATLAB, Simulink. I'm going to show you that. This is also important too, because whatever your data provider, your broker, if you know how to properly implement with these design patterns, it will make your system very flexible. And you can also easily apply new strategies and models and different agents and whatnot you can build in as part of your system. Now, for those that may not know, MATLAB or MathWorks has put out a new product called MATLAB Production Server. Now, I've always known about it. I've always really liked it. It's probably the most expensive component toolbox of MATLAB. But this video will mention on how to deploy that production server instance into a live, remote, virtually hosted system on an exchange. Unbelievable. And all your scripts are 100% compatible. I believe the metrics was 10,000 transactions per second. So it's got a lot of throughput. I just got to throw more workers at it, and that's where the costs start to add up if you want that type of performance. So mentioning this publicly from MathWorks, it sounds like it's very possible to do. Another last example, as I mentioned already, for HFT, for for whatever reason you want to use high frequency using C, C++. If you watch my video, I've already stated, we already know C and C++ are the standard languages when you really want to go true high frequency. Okay, that there is no argument on that. But again, to have MathWorks to publicly showcase the power of Simulink Stateflow and be able to build out real world market making strategy and show you how to use it is very powerful, and be able to visually build that. As I said, I have a video segment of that towards the end of this entire video, so please watch that. But right now I'm just going to hop into my Matlab and start running some stuff. Okay, so as you can see here, let me just show you where you can go and download your files right here. So I'll put that link in, and that's where you download them. Okay, so there's 2 demos I'm going to run in this video segment. The first one here is it shows you how to create a simple object. It's part of the design patterns, as I showed you, a lot of inheritance. It's really event driven, and it's going to stream data at a specific frequency. So let me just run this. I'm not sure if this will, yeah, no. Yeah. Okay, so what it's doing here is, you'll see this in the video, it will basically run all these different market assets and be able to have a unique timestamp. And then also grab the latest bid. Okay, so that's all event driven. So it's going to do some iterations, does 100 of them, so let's see what happens here. And then I'll give you a Sharpe ratio and what these strategies are. Actually, that's in the next video. Oh no, there's 2 different videos, and this is an automated strategy that will run, and it's going to tell you what each trader will do. Okay, and then you can also probably at the end of it track how those traders are doing. Okay, but I'll let you watch the video and play with the code. Second demo is very powerful in itself as well. This is for multiple traders. The first trader is a momentum trader. Second is a market maker, using those 2 different strategies and models I mentioned. Momentum trader's goal is to make profit. Market maker's goal is to provide liquidity with no profit loss with the trades. So the market maker will make rebates and other incentives from the exchange. That's pretty typical. Alright, so let me just run the second demo. And let's see what happens here. It takes a bit of time to load up. That's why I had to segment all these video segments just to allow the systems or these strategies to run. Can't remember how long this takes to run, but I believe, you know what, I'll pause it and come back to it. Okay, so I've been waiting around for the second demo to complete. Essentially, it does run, but does do some parallelization, and it takes up quite a bit of time. This is what it generates. It'll generate this figure, bid and offer, and then the other one will just basically calculate random trades from the various traders and agents. So you can see them buy, sell, and the price. Okay, so it does work. I just wanted to show that, and you'll see the same, basically the same issue where I have to terminate inadvertently the other demos as well. But at the end you will see that Simulink run for the Bayesian market maker. Hey everybody, running a version of this examples lead lag trader. Basically what it's doing is the program, if I can get this to cooperate, it might be better just to do it through this way. Looks like my Matlab's kind of busy. So what we're essentially doing here is running a back test of a momentum trade using two different moving averages. This is just part of it. It's currently using up my 4 workers. I'm going to try to show you the results here. It does open up a pool. I have 4 workers here, but it does go through, connect into a worker pool, does some parallelization. It's very slow, but I'm not going to tie up my system forever. It's been running for a while, but this is basically what it's charting, is the lead lag EMA results with an annual Sharpe ratio. These are the serial days of it running. This is the cumulative return. As you can see, each one of these is a position. These are signals of this automated trading system running. So I guess it's working in this mode at least. So it's kind of cool, I guess, but I'm going to stop this simulation, and it just continues. It just runs and runs and runs, and it's a nice example to work off of. See, I just updated something, but you know, this could take forever and blah blah blah. But it does seem to work. Works off of Microsoft. So let me just stop this. Okay. So not sure if my shut down the parallel pool. Yeah, it doesn't look like I can get all access to everything. But anyways, let me run the Bayesian market maker as well. Just to show you an example of that. Bayesian, this one. Okay. This may take a bit of time as well, so I'll let this run for a bit and then check back in another video segment. How exciting. Alright, so let me just show you another important, probably the most important part of this entire set of files when you download from Matlab Central is the Simulink model, this Bayesian market maker model. Okay, so if you come under market maker, load in this Simulink model. You can see here, it's fully explained in the video. Some very quick overview in the video. What I'm wanting to show you is it running and being able to co-generate in the C++ or C. I've gone over this a million times. I've been talking about this for probably a good couple of years now, but this is the very first example, real world use for building a high frequency trading model that you could deploy into a C system, a C++ system, or most of all, and I've talked about this a billion times, HDL for deployment, FPGA for ultra lowest latency. No other language does this, folks. Sorry. This is just the reality, and this is like live and direct. Okay, so I can run this model, no problem. There's 2 scopes here. They're divided up, as you can see here, on gain, market maker, A and B. We also have market maker position and the overall P&L. here, I can't remember what the demos. I think it's just another strategy result. So we have a state flow here. I'm not going to go into this in too much detail. Here's another model, a subsystem. And here's the state flow representation. Stuart does go through all of these different functions, but you can see that this is very doable. So those data sources are two data sources here, which are mat files, I believe. Signal from a mask from the workspace, and I believe so you must have run something in the background, and as well as another signal as well. But this is all fully explained in the video. So let me run it. And what you should pay particular attention to is this part that's running, feeding all the data through. You can see it run. Also, there are scopes being worked on live. Let me just blow up this one. As you can see, there's two different market makers here. So this is pretty powerful. I didn't even know. I mean, I knew about the capabilities of being able to chart like this, but to be able to work off a Simulink model is pretty powerful. So once again, you could easily deploy this into a C or C++. I'll show in a minute once we've completed this model. But it's pretty cool. You could run this real time. I've shown this millions of times, different examples, but again, first real world example, and specifically market making, which is pretty well used in high frequency shops. Not going to go on about it, but just living proof that this does work. All right, so we are almost done. Boom, there's a little ding dong that says everything's complete. Okay, so let's get into the code generation part, which is very powerful, of course. I'm just going to go under options. Now, the usual treatment I give it, I just like to comment on everything. Comments, the state flow and objects, Simulink blocks, Matlab source. Trace it back to the Matlab, and of course any blah 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 verbose comments. I don't think we really use that. Symbols, custom code we don't need, but again, we have shown demos thanks to another follower who's demoed this with interfacing with Redis. Ooh, that is so juicy to know. Of course, we got some other cool stuff. We talked about this. Let me just show you where to go if you want to learn more from my end. Just give me a second here while I type up where to go on my YouTube channel. So if you come under my channel here at youtube.com/quantlabs, come under video playlist, you will find a workflow, best workflow to HFT. It covers all the HFT stuff, but I'm also going to include this. And I'm telling you, man, this is the absolute way to do it. Okay, so we're sitting here in our code generation part. So let me just go back to the code generation part. So we've got C++. There is a way to load Visual Studio right up in the model, but you know, that's not really important. But we just press build. So what do we get when we build? Not going to do that. It takes a couple of minutes. I'm sure you don't want to waste your time. But here's the C++ code from that Simulink model. Here's some supporting functions from MathWorks. It's part of the build. There's, of course, our main CPP. So we're looking at a pretty substantially sized C program, it looks like. Oh, maybe not. I'm not sure. But you know, it does generate the C++ and you know, basically all the C++. So once again, let me just show you some comments. I've shown this many times here. This would refer to MATLAB function probability, I believe. This is powerful stuff, man. This is the actual MATLAB, or actually this might be the Simulink because it's a signal one, but it's got everything here. You can work off this, use it, and play around. But again, this can be deployed into high frequency trading for sure. All right, hopefully that'll help you out.